Okay, this is Mr. Peterson continuing with the notes in Algebra 2 for section 9.3, and we're on page 3. Now our goal on this page and part of the next page is to find the location of the horizontal asymptotes. And we've seen several of these. We just are making this more explicit here. How do you find the exact location of them? Okay, there are three cases. The first case is when the p of x, that'd be the top one, has a degree that's less than the degree of the bottom one. So this one has, since it has that x squared, with the second power there, it's degree 2. And this one, with a first power there, is degree 1. So what you see is you have this higher degree function is on the bottom. Anytime that happens, then you've got a predictable y equals 0 horizontal asymptote. In other words, the x-axis is your asymptote. So here's another example of that. You have a degree of 2 on the bottom. This is quadratic because of that second power on it. And this is constant, which has a degree of 0. Now you could stick behind that behind that 6 and x to the 0, and you remember that x to the 0 is 1, so 1 times 6 is what that is. And then it'd be really obvious that you have degree 0 up there. So at this point we examine it and we say, well, there's a higher degree on the bottom. Okay, your horizontal asymptote is predictable. It's y equals 0. In other words, the graph will get closer to the x-axis. As you go out on the extreme right and the extreme left, it gets closer to the x-axis. Okay, case number 2 is when the degree of p and q are equal. Then the horizontal asymptote is a fraction. It's a over b. It may not end up being a fraction, but it starts out that way. Where the a is the coefficient of the highest degree term in p of x, and the b is the coefficient of the highest degree term in the bottom, q of x. So if you look at this one, these are both degree 2. Let me do it correctly, n equals 2. And this one is also degree n equals 2. And so we have equal degrees, quadratic and quadratic here. And you look at the degree of that highest term, the 6, and the degree of the highest term down here, the 2. And so your horizontal asymptote is y equals 6 over 2, or y equals 3. And you can see it cutting right through here on this problem. Y equals 3 is your horizontal asymptote. In other words, this part of the graph gets closer and closer to that line, and this part of the graph gets closer and closer to that line as you go out on the extremes. Really strange graph here. Okay, so I'll pick up on the other side and show you case 3. And so if you're watching these videos in sequence, you need to watch both of these.